So we're looking at f of x equals, I'm going to make one up. Negative 2x plus 4 for x less than or equal to negative 2. X plus 1 for negative 2 to 3. And just x for x greater than 3. And you can say, yes, this one has 3 pieces. Yes, it does. The previous one we looked at had only 2 pieces, but that's okay. So we're asked to graph this function. Okay, so remember what if you're using the method I presented, if you use a different method, use your own method, that's fine. What I like to do is replace this by the interval notation negative infinity, negative 2. Is that okay? We agree? Is that correct, everyone? Okay, the middle here is negative 2 to 3 with a bracket. A parenthesis and negative 2, there is no equal symbol, and the bracket at 3 because there is an equal symbol. And the last one will be between 3 and infinity. Do we accept this? Interval notations are okay? Now, every time we're asked to graph a function, we have to find its domain. That's the first step. So based on what we just looked at, can anyone identify the domain of this function? Very good. Thank you very much, ma'am. Indeed. We have everything between negative infinity and negative 2. We have negative 2. We have everything between negative 2 and 3. We have 3. And we have everything between 3 and infinity. So it's all real numbers. Nice. So I can get my table going from negative infinity to infinity. Then I look at the function and I realize that it has 2 key x values that need to be in the table. Can anyone identify those key values of x? Of course, negative 2 and 3, and always remember 0 has to be there. Remember what we did last time? I copied what I see here under negative 2, a bracket to the left and a parenthesis to the right. Immediately under negative 2. I copied the same thing, a bracket to the left and a parenthesis to the right. It happens to be the same, immediately under 3. Now I will ask myself, although you may say this is redundant, this step you shouldn't even talk about, but I prefer writing the functions above on the table versus having to go back here and maybe I don't plug in the correct form. So can anyone tell us between negative infinity and negative 2 which function we have to use? Perfect, the first one, negative 2x plus 4. Between negative, and sometimes these are not arranged in the correct order, so that's why it's wise to identify them correctly. Between negative 2 and 3, good. And obviously the last one is just plain x. Perfect. So I chose all linear functions because we're going to talk about the rest of the functions later in the semester anyway. So I chose all to be linear functions. Okay, so I'm going to plug in some numbers, and I need for each piece, I need 2 numbers. Right? I don't need more, but I may have more, but that's okay. So when I plug in negative 3 in here, what do I get? 10, indeed. Perfect. When I plug in negative 2, 8. Inside the bracket, I write 8. Now, on the other side, you should say you're not allowed to plug in negative 2. And I will have to agree. But I will leave it as an open point. I have to plug in negative 2. It will not be in a point that exists, but it will be, because otherwise I don't know how close I should start to negative 2. It would be negative 1.9999999, but I don't want to work with that. I'll rather work with negative 2 and leave it open. So when we plug in negative 2 here, what do we get? Negative 1 inside the parenthesis. Let's plug in 0 and we get 1. And let's plug in 3 and we get it right inside the bracket. Also, please plug in 3 on the other side and you should say the same thing. You're not allowed to. I'm not. But I will leave it as an open point. So let's plug in 3 and we get, and let's also plug in 4 and we get 4. That's more than we need, or I should say basically it's really what we need. Good. So please read those ordered pairs for me from left to right. The first ordered pair is the next ordered pair is it a full point or an open point? It is a full point because of the bracket. Very good. Sorry, I didn't plan correctly. Okay, I'm done with the left-hand side. I can extend it. It's it. That's it. The next ordered pair is -2, -1. What type of ordered pair will that be? Yes, it will be open. 0, 1. I should also put -1 in here because it's a important. See what I did? It's -2, -1, and I put it under -1. Sorry, my apologies. Okay. So -2, -1, and then -1, 0, and then 0, 1, and then 3, 4, right? 2, 4. And what type of point is this? Very good, awesome. Kind of missed it a little bit, but you know. What I meant. Okay, perfect. Now on the other side, the last branch will have 3, 3. What type of point will be 3, 3? Open. And then 4, 4. Every time we have a test, or I give a test from this topic, students graph this. One piece is this and the other is this. Is that correct? No. By the vertical line test, this is not even a function. So as you see, this piece is alone to the left of -2. This piece is alone between -2 and 3. This piece is alone between 3 and infinity. You can't do something like this. That's not a function. But now by the vertical line test, this is a function. This one is not. So please do not graph something like that. Now, can we identify the range of this function? Without a graph, we couldn't, but now we can. From the lowest y value that may exist or not, till the largest y value where when I draw horizontal lines, I can still cross the function. Very good. And parenthesis at -1 since the function at that point does not exist. So this is how we address piecewise defined functions. On Monday, I will bring a previous test, and we are going to review and go over everything from that test. Okay? Any questions on how to graph piecewise defined functions? Is the idea clear? Yes? No? Maybe? Okay. Do you think we need another example, or we can move on? Another example. Would you like to choose? I'm looking at the end of the chapter at the review. Like I showed you, each chapter has a review to see if there is anything there that is interesting. Or the chapter test. Or I can make one up. Any preference? Which part, by the way, I would like to understand better, which part of all this is difficult or maybe not clear? Which part you have doubts on?
That's from the safety.
Which one?
Where D is.
The domain?
Here.
The table?
Yeah.
So I put these values in because these are values of x where the function changes from this to this or from this to this. So these are very important values, -2 and 3. 0 has to be in the table. And then I copy each function where it belongs, and I plug in numbers. So this function belongs here, this function belongs here, this function belongs here. That's why I put them up there. So I have to pick some ordered pairs. So I picked -3, and I mean some x values to determine the y value. So I picked -3 to get 10, -2 to get 8, and so on and so forth.
So
Yes. Before we choose the next example, it's better to discuss what could be.
So why is the second?
This?
No, not talking about the graph. No. The graph.
Oh,
Why is the second one pointing up?
this one?
Yeah.
That's what I got. -2, -1 is here. -1, 0 is here. 0, 1 is here. And 3, 4 is here. I have no choice. I have to connect the points. I plotted 1, 2, 3, 4 points. I have to connect them. I can connect them like this. I have to go through, it's a linear function, so it has to go from this point to this point through each point. It has a positive slope also. This one has a negative slope. So this piece is a linear function with a negative slope. This piece is a linear function with a positive slope. This piece is a linear function with a positive slope. I can't change that.
So doesn't the arrow mean it's
Say it again.
Doesn't the arrow mean that it's
Only here and only here. So this one is carved in stone between -infinity and -2. So it can have an arrow pointing to -infinity, to this side.
Okay.
This one in the middle is carved in stone between -2 and 3. I can't point anywhere. Very good question, actually. And this one, since it's anywhere between 3 and infinity, of course he will have an arrow here, but he cannot have an arrow here. It's a very good question. Thank you. Is that clear?
Yes.
Do you all understand the question? Yes? It's a very good question. So the question is, why can't I put an arrow here, basically, or arrow here? Because this is blocked. This one is not blocked to the side, to the right. This one is not blocked to the left, but this one is completely blocked, carved in there, right? It's boxed in.
By any chance, could there only be like 2 arrows? Like, for example, the middle one that's blocked isn't in the equation at all.
You can't extend it. This function is only between -2 and 3. That's it.
No, I mean,
Oh.
there's an equation that would equal to only like 2.
Yeah, that's only at the ends. You cannot have an arrow in the middle. Because if you have an arrow in the middle, then it will not be a function. So you have these two pieces, and that's not a function. By the vertical line test, it's not going to be a function. So they will never be overlapping, ever. No piece will overlap with any other piece at any point in time, because it will fail the vertical line test. Okay, do you have another piecewise defined function for me, or should I make one up? Okay, very good. 2 branches or 3 branches?
3.
Okay. Let's do it 2 now. Okay, so -1/4 x plus 1 for x less than or equal to 2, and 2x plus 4 for x greater than 2. First, we have to identify the domain. And like before, please change this if you are using my method. Please change this into interval notation. Can anyone give us the interval notation for these two? Very good, awesome. Negative infinity to 2 to infinity. Now can we identify the domain? This is not going to be the case all the time when the domain is all real numbers. But in this case, we have indeed all real numbers. That's the domain. Nothing is missing. We have everything to the left of 2, we have 2, and we have everything to the right of 2. So the next step is I need to put that, in this case, how many key x values we have. In the previous case, we had 2, negative 2 and 3. And how many we have now? Just one. But also remember, 0 must be in the table. And you may have to make sure that these numbers are in ascending order. You cannot put 2 on the left-hand side of 0. Be very careful. So now I copy under 2. What do I copy? What symbols do I copy under 2? Yes, a bracket to the left because it opens to the left, and a parenthesis to the right. Perfect. Now I have to establish which function goes where. Between negative infinity and 2, I will be using which function? Negative 1/4 x plus 1. Very good. And obviously on the other side, 2x plus 4. Notice that I chose again a linear function, so we don't have to think in terms of radical or quadratic, or we have time for that. Okay, so I see that when I plug in negative 4, and this is an important point, what do I get? What is the function value when x is negative 4 here? Actually, it is 2, you're right. So it's just a nice number. Okay, so when I plug in 0, I get 1. And now when I plug in 2, I get negative 1/2 plus 1, which is 1/2. We plug in 2 on the other side, and we get 8. And we plug in 3, and we get 10. So we got a few numbers on this side and 2 on this side. We got 3 on this side and 2 on the right. From left to right, first ordered pair I have to present, negative 4, 2. And then 0, 1. And then 2, 1/2. And this is a full point. And then I have 2, 8. And that is a open point. And then I have 3, 10. And again, I did not plan ahead. Can anyone identify the range for us? 1/2. 1/2 to infinity. Very good. Is this better? So please remember to redo all problems we do in class. That's the first step for you on your learning process. Your learning process starts with redoing the problems we do in class. Okay, the last two sections before our first test, 2.3 and 2.4, they only talk about linear functions. In other words, lines. The reason I present them together is because they belong together. The second one, 2.4, is a slight extension of the first one. So we will talk about problems and equations and all the information here. We're going to go over everything. Okay, so does anyone remember how many types of lines we have. I'll show you the types, and then we'll discuss each and every one of them. Yes, 4 indeed. These are types of lines, 4 types of lines. This one that goes up from left to right, like I show it sometimes like this, is a line with a positive slope. Anyone remembers how we denote? What is the notation for the slope? Lowercase m. That's slope. Slope. What does the slope mean? It's the steepness. How steep is the hill that I'm going to hike on? That's the slope. What do you think about the second one? The second one is a line, but this time with a negative slope. This one is a horizontal line. The slope is 0. Very easy to walk on. Slope 0. Comfortable. And this one is a vertical line. And this one has no slope. Undefined. The slope of the vertical line does not exist, or we say it's undefined. Does anyone remember how we determine the slope if we have 2 points? So please give me 2 points. Any 2 points you want, and let's determine the slope of the line that could pass through those points. Say it again. -2.
6.
Good.
10.
Good.
30.
Excellent. Good. So this is our first point, x1, y1, and this is the second point, x2, y2. And we want to determine the slope of the line passing through those points. The definition is rise over run. Good. Definition first, and then we'll plug in. Excellent. y2 minus y1 over x2 minus x1. Please do not reverse them. You have to have first at the top the difference in y, and at the denominator the difference in x. So all I have to do now is just carefully plug it in. 3 minus 6 at the top, and 10 minus -2 in the denominator. Minus -2 changes the sign, so the top is -3. The denominator is 12. We simplify that negative over a positive is negative, and 3 over 12 is simplified into, that's it. Excellent. So given 2 points, this is the way we determine the slope of the line that could pass through those points. Perfect. We do have 2 equations of the line. 2 equations of a line. One is slope-intercept form. Slope-intercept form. The second one is point-slope form. The question is, when do I use, or we're going to write them in a second, but the question here is, when do I use this? When do I use this? This works always. Always. For any point, you can use this. This one is specifically for when you are given the y-intercept. So this one is y equals mx plus b, where m is the slope. And this number basically comes from the y-intercept, which always has 0 as x, and some number. And this number is the b value. So let's look at an example right here, just for a second. Let's say y equals negative 1/4 plus 3. Of course, 1/4 x, sorry. Can anyone identify the slope here? Yes, because we compare, right? So the slope is negative 1/4. And can anyone identify the y-intercept? 0, 3. Any questions on this? Any questions? Okay, let's refresh our memory on the second form. Y minus y1 equals the slope times x minus x1, where of course this is the slope, and this x1 comma y1, x1 comma y1 is the point. Can it be 0 comma 3? Yes, it can. But if you have 0 comma 3, it's easier to use this. But if you have 5 comma 3, it's easier to use this equation. Before we work on more problems, I would like to refresh your memory on parallel and perpendicular lines. Any questions on this? Yes? So I can use this one for any point you give me, including 0 comma 3, but I will have more work to do. The best thing to do is when you have anything but 0 comma. When you have 0 comma, you should use this. It doesn't really matter.
So you thought 3 was
You mean here? y2 minus y1, 3 minus 6. x2 minus negative 2. Was it okay?
I was wondering as far as B, like how you got 0.
Oh, so this is the equation I just wrote. So this must be the slope. And this must be the y-intercept. The y-intercept always is on the y-axis, which means x equals 0. So 0 comma 3 is 0 for x, 3 for y. Maybe I didn't understand the question.
I was just wondering why was it 3? Like how did you come up with 3?
It's from this equation. I created this equation, and I was asking, let's find the slope and the y-intercept. By simply looking at the equation, we identified the slope to be negative 1/4, and we identified the y-intercept to be positive 3. But it has to be 0 comma 3. Better? If I had negative 5, it would have been 0 comma negative 5. If I had positive 10, it would have been 0 comma 10. But 0 is mandatory because it's a point on the y-axis, which all points on the y-axis have x0.
So that equation has nothing to do with the problem we solved right above it. It's just what you made up.
Yes, because I wanted to make sure that everyone understands how to read the slope once the equation is solved for y, how to read the slope, and how to find the y-intercept. And also going backwards. If I ask you to create an equation that has the slope negative 1/4 and the y-intercept 0 comma 3, what will you write?
Y equals negative 4x.
Negative 1/4 x plus 3.
I was saying what she said. I thought it had something to do with the problem that you did before that. That's why I was like, where did 3?
No, that's why I separated it. Sorry. You mean from here?
No, from the one above it, the negative 1/4. It looks like you pulled the negative.
Oh,
1/4
no,
into
it was by coincidence. I'm
And
sorry.
that's why when you were telling, I was like, okay, you had nothing to do with
No,
that.
no, I'm so sorry. Okay. Okay, do you want me to change the negative 1/4? I'm going to change it into 3/4. Good point. I didn't think. I didn't want to confuse you with this. Of course not. So no, I just made one up to see how we use the slope-intercept form. Sorry, my apologies. Good. Perpendicular and parallel lines. Parallel. Perpendicular. Okay, so these two lines are parallel, and these two lines are perpendicular. 90 degrees, all over the place. The first line has slope m1, the second one has m2, the first one has m1, the second one has slope m2. What is the relationship between the slopes of two lines that are parallel? They are equal. Very good, awesome. The slope of the first line has to equal the slope of the second line. Perfect. Now we want to identify the relationship between the slopes of two perpendicular lines. Negative multiplicative inverses of each other. I don't like that. I like to say the product is -1. I know you remember it like this. It's the same thing. If you cross multiply, you get that. So is it easier to say one slope is the negative multiplicative inverse of the other? Or is it easier to say the product is -1? It's up to you. They mean the same thing. Okay, we're ready now to look at different problems. Let's start with 26. That's the entire theory behind these two sections. There is nothing else. 26 on page 267. But we need to practice everything. We're asked to find the equation of the line passing through the given points. What we need to determine, first of all, let's establish, are we given the Y-intercept? No, we're not given the Y-intercept. Perfect. So I will not think of y equals mx plus b. There is no point. Okay, so what do I have to determine first? And maybe we should establish this from the very beginning so we don't make a mistake. It doesn't matter. My order was 1, 2. Your order can be 1, 2. It doesn't matter. We have to find the slope. Thank you. I recommend always write y2 minus y1 so you remember it forever over x2 minus x1, and then carefully plug it in. 15 minus 5, which is 10, and 8 minus 3, which is 5. Nice slope, 2. I didn't mean to choose a nice slope, but it is. At this point, I will think of y minus y1 equals the slope times x minus x1, and it doesn't matter which point you use. If you want to use point 2, it's fine. If I use point 1 and you use point 2, it's not going to make any difference. We both will get the same equation solved for y. So which point would you like to choose? The small numbers? We should always choose small numbers if possible. So here's what I like to do. Again, adopt the method if it works for you. If you like it, if not, forget about it. I write these numbers underneath, so I don't have to write it again. Or twice. I have to write it once. So this is y minus 5 equals 2x minus 3. Especially when they are negative, then I will write directly with the correct sign. I have to distribute 2, so I get 2x minus 6. And I have to bring the 5. It was negative, and now it's positive. I have to solve for y at all times. So y equals 2x minus 1. Can anyone tell us what does this equation represent?
Slope of the Y-intercept.
It represents the equation of the line passing through these points. It's guaranteed. This is the equation of the line. If you plot these 2 points and you graph this line, it will go guaranteed through these 2. It will pass through those 2 points. Questions? Okay, that's one type of problem. Let me know if you need more of the same. You should always tell me if you need more of the same without me asking, please. Here's the second type. 64 on 267. 6x minus 5y minus 20 equals 0. We're asked to graph using x and y intercepts. Graph using x and y intercepts. So let's look at the Cartesian system for a second. So this is the x-axis, and this is the y-axis, and this is the origin. Can anyone give us the equation of this line? All lines, say it again. Do we all agree with y equals 0? Yes? Yes? This is altitude 0. This is altitude 1. This is altitude 2. This is altitude -1. This is altitude -3. So this is altitude 0. Okay, can anyone give us the equation of this line, which is the y-axis? Yes, the position. This is position equals 0. This is position equals 1. This is position equals 10. This is position equals -5. So when I'm asked to graph using x and y intercepts, I make x equals 0, and I determine the corresponding y value. Then I make y equals 0, and then I determine the corresponding x value. For that reason, because this is y equals 0, and this is x equals 0. You please do not waste your time solving for y. You're not going to use the slope to graph. Please. So I make x equals 0, and I simply cover this. I get -5x equals +20. -5y, I'm sorry. +20. How much is y? -4. What is the ordered pair that we just determined? 0, -4. Do you all agree with this step? I can repeat it if we need to, please. Yes. So I make x equals 0. I covered it because this term goes away. When x is 0, this goes away. So I have -5y equals +20. I divide by -5 to get -4. That's how we got this ordered pair. 0, -4, which is here. Now we'll make y equals 0 to determine the x-intercept. So I cover this now. So I have 6y equals 20. Of course, I meant x. So then x equals 20 divided by 6, which is 10 divided by 3. What is the ordered pair that we just determined now? 10/3, very good, comma 0. 10/3 is a little bit more than 3. 3 and a little bit, and 1/3. So this is the graph of the line in question. Connect the points and extend. You can put the arrows. There is no limitation for this. But please write the equation somewhere. 6x minus 5y minus 20 equals 0. And this is the way we graph using x and y intercepts. Let me know if we need to show another example. Of course. Okay, so let's look at 72. 6x minus 3y plus 15 equals 0. Same page, 267. Do not waste your time solving for y. There is absolutely no need. It's going to be in the way if you do. It's not a good idea. So when x is 0, negative 3y equals negative 15. How much is y? Excellent. What is the ordered pair? Do we understand the process so far? Yes? Okay, the other one, I make y equals 0. I have 6x equals negative 15. So then x will be negative 15 over 6. And I will simplify by 3. And by 3 as well, negative 5 halves. So the ordered pair is negative 5 halves, comma, 0. Now I will plot. So careful, do not be, because you may be tempted to combine this into an ordered pair. Be careful. I set x equal to 0 to find the y-intercept. And I wrote the ordered pair before I moved on to the next ordered pair. You must do that. 0, comma 5. Then I will not by mistake put this point as negative 5 halves 5. That's not the case. Absolutely not. So after I'm done with that, then I continue with y equals 0 and I determine x, and I have negative 5 halves, and 0. Do not combine something like this. That's not going to work. Be careful with that. So now I'll plot these 2 points, connect and extend the line. So this was graphing lines using x and y intercepts. So 0, comma 5, negative 5 halves, that's 2.5 right here. Connect and extend, put arrows, finish up the Cartesian system or coordinate system, and write somewhere 6x minus 3y plus 15 equals 0. So I know what I graphed. We always write the function or whatever it is somewhere next to the graph. Below the graph, above the graph, top, bottom, whatever you want to write it, but it has to be written somewhere. Questions? Any questions?
Is there an example of where there's a fraction in the equation?
Yeah, we can always have a fraction, sure. Let's say 1/2 x plus 2/3 y equals 6. What do you think? So I'm asked to graph this. What do you think I'm going to do next?
Set x to 0.
Nope.
Subtract 6?
Nope. No. There, exactly. Remember 2 key words, factor and simplify. I don't want to work with something like this. Of course not. I'm going to multiply both sides by the least common denominator and get rid of all these fractions. It's just one step. 6 divided by 2 is 3. 6 divided by 3 is 2 multiplied by 2. And 6 times 6 is 36. I don't care for that. I'm going to graph this. Not because I'm afraid of fractions, but because the work is much easier without fractions than, and I only have one intermediate step. Multiply both sides by the least common denominator, get this, and now when x is 0, y is 9. When y is 0, x is 12, and I'm done. It will take me a while to plug in and move to the other side and find y and find x, y. There's no need. You can always, in one step, get rid of fractions. So now the line will be, so I'm going to use a unit of 3. 3, 3, 3, 3. And I'm going to, that was 0, 9, sorry, right here. Just 3, 3, 3, right here. And x12. 3, 3, 3, 3. So here it is. So this is 12, this is 9, and this is the line 1/2 x plus 2/3 y equals 6. It's a very good question. Thank you for asking that. Any questions? Is that clear? No one can force me to work with fractions. I can always go around that if I need to. Well, sometimes I have no choice, but in this case, a simple multiplication of both sides by 6 did the trick. Clear? Very good, awesome. Thank you. Whenever you ask questions, you're not just helping yourselves and your colleagues, you're helping me, because I would have never thought of presenting something like that. Okay? Because sometimes we think about eliminating fractions, sometimes we don't. So I didn't think. So that was a perfect example for you to see. Thank you. Thank you very much. Okay, I'd like to look at a word problem. Let's see what they want us to do. I have no idea, but they are showing us some graphs in here. So it's a long. So we're getting apparently married later in life, or not at all. In 2010, more than half of Americans ages 25 through 29 were unmarried. The bar graph shows the percentage. Shows right here, bar graph shows the percentage of never married men and women in their particular age group for selected years. The data are displayed as two sets of 4 points each, one scatter plot, so right here, for the percentage of never married American men, and one for the percentage of never married American women, so male and female. Also shown is the line. Okay, the scatter plot and the line. Perfect. So you would like to look at the line for women or the line for men. So one is here and one is here. So women and men. So men are in red, women in blue. Male, the scatter plot and the line is in purple, and for female in blue. Are you interested in talking about percentage of unmarried men or women? Women, perfect. Okay, so that's problem 88. I'm going to write it down in a second. 88 on page 268. In this exercise, you will use, no, I'm sorry, it's 87. 87 is for women, sorry. In this exercise, you will use the blue line for the women, shown on the scatter plot. That's the scatter plot. This is the bar chart. To develop a model for the percentage of never married American females aged 25 to 29. Use the 2 points. We are given 2 points. We are given 20, 38.9, and we are given 30, 47.8 to find the equation of the line that models the percentage of never married American female ages 25 to 29. Y is that percentage, and X years after 1980. Okay, so I have a lot of information to copy down before I even think what I need to do. So first of all, this is problem 87 on 268. We are given two ordered pairs. We read them as 20, 38.9 and 30, 47.8. So X is the number of years since, there's an R here, sorry. Since they said 1980. And Y is the percentage of never married. Y, percent of never. Perfect. One more time, in part A, they're asking us to find the equation of the line that goes through the given points. Nothing new. We've just done that a few minutes ago. So how do we start?